Hi maths students, I'm Mr. Hajkasim, and today we're going to learn about box and whisker plots. Now you might just hear the shortened version of this, so throughout the slides I will refer to box and whisker plots as just box plots, but it is the same thing. Now, a box plot is a way of illustrating key information about a set of data, and they are very useful for comparing the distribution of two sets of data. Now, this is what a box plot looks like, and the key values that we need from a box plot are the minimum value, the lower quartile, the median, the upper quartile, and the maximum value. So in essence, our data split up into 4 quarters. So this would be the first quarter, this would be the second quarter, this would be the third quarter, and the fourth quarter. And the interquartile range is essentially the difference between the upper quartile and the lower quartile, and we will discuss this in further detail shortly. So again, going back to what we mentioned, the quartiles split the data into quarters. So the lower quartile is 1/4 of the way into the data. The upper quartile is 3/4 of the way into the data. The median is 2/4, which is essentially a half way into the data. So when ordering data, or when dealing with data and you are asked to draw a box plot, what you need to do is to order that data from smallest to largest, or in ascending order. Now here we've written ascending height order, but it's actually from the smallest value to the largest value. So this is very important, because if you don't order your data correctly, your values, the quartile values that you're looking for, will not be correct. Okay, so what information do we need to be able to draw a box plot? Going back to the first example, we need a minimum value, we need a lower quartile, we need a median, we need an upper quartile, and we want the maximum value. So let's start here then. So this is the data for the number of goals scored in 7 seasons by a specific footballer, let's say Marcus Rashford, even though this data is not true for Marcus Rashford, but hypothetically speaking. So what we want to find, or the easiest values to find, will be the highest and the lowest value. Now first check to see if your data is ordered, and in this case it is. We have 1, 5, 9, 10, 11, 12, and 15. So our lowest value is equal to 1. The next easiest one would be the highest value, which is 15. So highest value is 15. Then try and find the median. And the median is a type of average, and that's essentially the middle value of your data set. So in this case, the middle value of our data set is 10. And we can find this out by crossing off a value from the left and the right. So I can cross off a value from the left, from the right, from the left, from the right, from the left, from the right, and 10 will be in between these 3 numbers and these 3 numbers. So we can see we have 3 numbers to the left of 10 and 3 numbers to the right of 10. So 10 is bang on in the middle of the data set. So the median is the middle value, and the middle value of this data set is going to be 10. Now, if I just clear what I've done, now to find the lower quartile, the lower quartile is the median of your lower half. So we have 3 values in our lower half. So this is our lower half here, and this would be our upper half. So the lower quartile is the median of the lower half. So in that case, if we cross 1 from the left, 1 from the right, 5 is going to be the lower quartile. So we can say, and I'll just label it as LQ, lower quartile is equal to 5. We then need to find the upper quartile. So the upper quartile is the median of the upper half. So these 3 values are the upper half of our data set. So again, if we cross one from the left, one from the right, 12 is going to be bang on in the middle. So the upper quartile, or the median of the upper half, is going to be 12 in this example. All right, now with this example, it's slightly trickier because we have an even amount of numbers in our data set. Here we have an odd amount of numbers. We've got 1, 2, 3, 4, 5, 6, 7. So it's quite easy to find the median. You will have an even amount of numbers on either side of your median value, but here it's not going to be quite as straightforward, and I will show you why. I'm just going to clear, actually I won't clear the drawings, I'll leave them there, just use a different color pen. So let's use green for this example. So if I was to find the lowest value, again, our data is ordered. So our lowest value in this case is going to be 1. My highest value is going to be 16 goals. And then we want the median. Now, in this case, if we were to use this approach of crossing a number from the left, crossing a number from the right, it becomes a little bit tricky, and you will see why. So 1 from the left, 1 from the right, from the left, from the right. Now I have 2 values here. If I was to cross a 10 off, I would have 4 numbers to the left of 11 and 3 numbers to the right of 11. If I was to cross off the 11, I would have 4 numbers to the right of 10 and 3 numbers to the left of 10. So actually what we need to do is think about these 2 numbers and find the middle value between these 2 numbers. And the middle value between 10 and 11 is going to be 10.5. So 10.5 is going to be your median. And another way of finding the middle value of 2 numbers, or the midpoint of 2 numbers, would be to add them and divide them by 2. So we could have done 10 plus 11 divided by 2. That will give us 21 over 2, which is equal to 10.5. So the median is 10.5. And this is a method of finding the midpoint of 2 numbers, so the midpoint of 10 and 11 in this example. Now, if I just erase this to give us a bit more space. So 10.5 is our midpoint. So now to find the lower quartile, what we need to do is to find the median of the lower half. So again, I'm just going to use my rubber here. And the median of the lower half, similarly, the middle value is going to be between 5 and 9 in this case. If I was to cross out 1 from either end, I will have 5 and 9 in the middle. So I want the middle value between 5 and 9, which is going to be 7. So the lower quartile is equal to 7. And again, if I was to do 5 plus 9 divided by 2, that will give me 14 over 2, and 14 over 2 is 7. Or you can just sort of count what the middle number is between 5 and 9. We'll have 8, 9, so 2 numbers to the left of 7, and we would have 6 and 5, which is, 2 numbers to the right of 7, and 6 and 5 would be 2 numbers to the left of 7. Okay, now we need the median of the upper half to find the upper quartile. So likewise, the 2 numbers that we're looking for are 12 and 15. So we want the midpoint, or the number in the middle of 12 and 15. Now with this one, it might be a little bit tricky. So what we can do is add the 2 numbers up. So 12 plus 15 divided by 2, that will give us 27 divided by 2, which will give us 13.5. So 13.5 is bang on in the middle of 12 and 15. So the upper quartile is going to be 13.5 in this example. So again, notice when you have an odd amount of numbers in your data set, it's a lot easier to find the median, lower quartile, and the upper quartile. When you have an even amount of numbers in your data set, it becomes a little bit more tricky, and you need to be able to find the midpoint of two numbers when you have a situation like we have in this example. So most important thing, to be able to draw box plots, you need to identify your lowest value, your highest value, find the median, find the lower quartile, and find the upper quartile. All right, and I'm going to clear the drawings, and we can do an example now. So here it says Millie is a basketball player, and she recorded the number of points she scored across 7 games. So in game 1, she scored 10 points, in game 2, 17, in game 3, 5, in game 4, 25, and so on. So we need to order the number of points scored starting from the smallest amount to the largest amount, so in ascending order. So what you can do is start with saying, well, 5 is the smallest number, cross it out so you know you've dealt with it. So we can write, and I've got this here, 5, then we have 10, so 5, 10, then we have 16, then we have 17, then we have 18, then we have 20, and then we have 25. So our numbers have been ordered in the right way. Now, again, we need to find the lowest number of points she scored. So the lowest number of points is going to be 5. The highest number of points is going to be 25, and the median, so in this case we have 1, 2, 3, 4, 5, 6, 7 numbers, so it's going to be quite easy to identify the median. Median is going to be, if we cross off 1 from the left, 1 from the right, left, right, 17 is going to be bang on in the middle, so the median is 17. And to find the lower quartile, we need the median of the lower half. So in our lower half, we have 3 numbers. So of these 3 numbers, so this is the lower half, and this is the upper half. The middle number of the 3 numbers is going to be 10. So 10 is our lowest quartile. Whoops. And I will just circle this and label it as the LQ. The upper quartile is going to be, well, the median of the upper half is going to be 20. 20 is between 18 and 25. So that's going to be our upper quartile. And then the median is 17. The lower quartile is 10. And the upper quartile is 20. There we go. And I'm just going to rub out some of the drawings so it makes easier sense. Once we have identified these values, we then need to plot them on a grid, or a number line. So our values were 5, and this is where you need to use a ruler. So we go to 5, and maybe I can draw that slightly better actually. So there we go. So from 5, we can draw a nice line. So that's your lowest value. Then we need our lower quartile. So our lower quartile is 10. So then we go to 10 and we draw a line here. And again, I think I can do a better job. There we go. Slightly trickier than I imagined. There we go. From here, that would be 10. And then we need our median. So the median is 17. So at 17, we'll draw another line. And then our upper quartile is going to be 20. And our highest value is going to be 25. Now again, when you have a ruler, you tend to have squared paper, so it's quite easier to see what's going on. Then we just join the points up, so we can draw our box here. This is what our box would look like, and then we can join this up like this. And this is our box plot for the number of points Millie scored. So the lowest number of points was 5, the highest number of points was 25, and the median, as I said, is an average, so the average amount of points scored was 17. And you can find the interquartile range. The interquartile range tells you how consistent the data is. So the lower the interquartile range, the greater the consistency. So we can find the IQR. So the IQR, or interquartile range, will be the upper quartile minus the lower quartile. And in this case, the upper quartile is 20 and the lower quartile is 10. And that will give us an IQR, an interquartile range of 10. Now, currently, this doesn't make, too much sense in the sense that we don't have anyone else to compare her with, or another set of 7 games to compare her consistency across, the first 7 games or the next 7 games. But if we were to compare her data, this would come in hand, because we can see whether she's more consistent than another player, or whether she was more consistent in the first 7 games she played compared to the next 7 games she played. All right, so moving on, let's do another example. And if I just clear all of this. Sorry, adjust my camera slightly. Right, so we have another example here. It says a sample of 10 boxes of raisins has these weights. Draw a box and whisker plot to represent the data above. Now, in this case, our data is not ordered in ascending order. So we need to order our data. And let's find our smallest value. So our smallest value is going to be 25. Cross it out and write it for yourself, so you know you've dealt with it and you don't end up repeating it. The next smallest value is going to be 28. Again, cross it out, so you know you've dealt with it. Next smallest values are going to be 29 and 29 again. Cross them out, so we know we've dealt with them. The next smallest value is going to be 30. The next smallest value is going to be 34. And then we have 2 35s. And then we have 37 and 38. All right, and just count how many numbers you've written down. So you've written 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Do we have 10 numbers? Yes, we do. The question also tells us a sample of 10 boxes of raisins. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you've included all 10 numbers. So you should be pretty confident that this is correct. And you can just count 25, 28, 29, 29, 30, 34, 35, 35, 37, 38. So our data is clearly ordered from the smallest value to the largest value. Now, what do we need to find? So we need our minimum value. Our minimum value is going to be 25. So we can draw this at 25, or we can start drawing our box plot at 25 as our lowest value. Our highest value is 38. So that's going to be 37, 38, 39, 40. So 38 is here. Again, make sure you're using a ruler. And then we can find our median. So I'm just going to use a different color pen. In this case, as we have 10 values, it's going to be slightly harder to find a midpoint, because if we were to cross a number off from the left and then the right, 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 we'll have 2 values in the middle. So we need to find the midpoint of 30 and 34. The midpoint of 30 and 34, you could do 2 methods. You could either do 30 plus 34 divided by 2, which will give us 64 divided by 2, which will give us 32. Or you can just count and see that 32, there's 2 numbers from 32 to 30, and there are 2 numbers from 32 to 34. So 32 is our median. It's the middle value of our data set. So we can draw a straight line at 32 to represent our median. Now, if I just rub out, or actually I would have to undo, so we said 32 is the median, and I will draw that again. All right, so the median is 32. Now we need to find the lower quartile. So if 32 is here, this will be our lower half, and this will be our upper half. So now we need to find the lower quartile, and in this case, it will be quite straightforward to find the lower quartile, because if I take one from the right, one from the left, from the right, from the left, 29 is going to be the midpoint of these numbers, or the middle value of these numbers, I should say. So this is going to be our lower quartile. Likewise here, one from the right, one from the left, one from the right, one from the left. 35 is going to be our upper quartile. So I know my lower quartile is 29, and I know my upper quartile is 35. Just need to plot the points on here. And if I go back to green, so we said lower quartile is 29, median is 32, and the upper quartile is 35. And then join the lines up together, and this is what our box plot will look like. Again, as you will have grid paper or squared paper, it will be quite easier to draw your box plot, but make sure you're always using a ruler as you do it. And that's it for this example. So if I clear all the drawings and if I move on, now here you might be given questions where you have to compare box plots, and this is where the IQR will be quite handy. Now, to compare box plots, there are three things you need to look at. So in this case, we're looking at the weights of boys and girls. First, look at the median, because the median is a type of average. So in this example, we can say on average, boys are heavier than girls as they have a larger median. And that's true, because the median for the boys is approximately 42. The median weight for the girls is just over 35. So this statement will be correct. Then think about the interquartile range or the range. Now, the interquartile range is usually a better comparison of consistency, because the lowest value and the highest value may well be outliers. So the IQR is a better measure of consistency. So in this case, we can say, so to calculate the IQR for boys, the IQR is 35, and we can say 48. And here our lower quartile is 30, and upper quartile we can say roughly about 43. So the IQR for girls is going to be the highest value, the highest upper quartile minus the lower quartile, which is 30. And that will give us an interquartile range of 13. For the boys, and I'll just write over here, the IQR is going to be 48 minus 35, which again will give us 13. So in this case, it might be better to use the range to make a comparison, but you can say the IQR for both boys and girls is the same, therefore there is equal consistency in the spread of data. And then lastly, you can make a general statement about, the heaviest boy or the heaviest girl, or the lightest boy or the lightest girl. So what we can say is the heaviest boy weighs more than the heaviest girl. So the heaviest boy weighs around 64 kg, whereas the heaviest girl weighs around 58 kg. So three statements to consider when comparing box plots. Think about the median, so that tells us the average of our data set. Think about the interquartile range, or just the range in general. The range would be the highest value, the difference between the highest value and the lowest value, and that tells us about the consistency of the data. And then think about a general statement. So what can we say? Can we make a general statement about the box plots that we have? Right. So let's do one more example. So here we have two weightlifters by two Olympic weightlifters. So the weights lifted by two Olympic weightlifters are shown in the box plots above. Compare the performance of the two weightlifters. So first, we can start with the median. So the median is actually higher for Tien Tao. So we can say, on average, Tien Tao lifts more as his median weight lifted is higher. So that would be one mark. The second mark, we can look at the interquartile range to see who's more consistent. So again, without doing any calculations, it's quite obvious that the interquartile range for Tien Tao is far smaller. The difference between these two values, so the upper quartile and the lower quartile of Tien Tao, is far smaller than the difference between the upper quartile and the lower quartile of Rostami. So we can say Tien Tao is more consistent. Tien Tao is more consistent because of a lower interquartile range. And if you wish, you can make that calculation as well. And then for the third mark, we said make a general statement. However, so the third mark could be, however, Rostami has lifted the highest amount between the two athletes. So Rostami's best lift is better than Tien Tao's. And this actually makes an interesting comparison, because this could well be an outlier. So it may well be that Rostami had a really, really good day. Or if we were to think about the use of performance enhancing drugs, could well be that on this occasion, Rostami may have been using performance enhancing drugs. I'm not saying that is the case, but that may well be an outlier, or it could be an indication of other things. So that's that for box plots. They're fairly straightforward. What we need to do is to be able to order our data, find the highest value and the lowest value. So this is the highest value, plot it. This is the lowest value. Then to find our lower quartile, so this value here, 60 for Rostami, is your lower quartile. The median is going to be, we're going up in 5, so that's going to be 65, 70, 75, just over 75, let's say 76. So this is going to be the median. And then this is going to be the upper quartile. Once you have your lowest value, your lower quartile, your median, your upper quartile, and your highest value, you can easily draw your box plots. And we can use the box plots to compare the distribution of data. As in this example, where we compared the median weight lifted, where we compared the consistency of the two athletes by using the interquartile range, and then we made a general statement. Thank you very much for watching, and I hope you found this useful. Have a nice day.